Right, on to example 3 for log equations, and remembering those 3 points again to get a single log on one side of the equation and solve. Make sure all logs have the same base, change the base if necessary, and logs are only defined for positive numbers, so we'll reject any solutions that give the log of a negative number. Back and when we check it. Okay, now the new thing about this guy here is that we haven't got the same base. If we look carefully there, we see one of those bases is an x and one of those is a 2. So we have to cross that off. We don't have that. And we also don't have a single log, so none of those two are working. So let's try and fix that. How do we change the base? Well, we go back to our laws of logs, and what we'll write down here in the top corner is how to change the base of a log. And the rule as written down from the log tables is log to the base b, log to the base b of x. Let's use different colors for these two, okay? And that's equal to okay, so how do you do it? Well, you make a fraction, okay, and we put a log on top and a log on the bottom. And the thing to remember is that the old base, that's b for base, he goes downstairs, right? So he's going to be there. And the old argument, this thing that is in front of the log, is called the argument of the log. He stays upstairs. And you can insert any base you want in that new fraction. So log to the base b of x is equal to log to the base a of x all over log to the base a of b. Okay, so just remember the old base goes downstairs and the old argument stays upstairs. You can change to the new base anything you want. Okay, so the problem we have is that all this here needs to be changed. We're going to change this guy because he has an x in his base, and we want to get him, the base, to be changed to base 2. That works. So, okay, putting in log to the base x of 2, log to the base x of 2. We want to change him to base 2. How do we do it? Okay, so equals, we have a fraction. Okay, we have a log on top, we have a log on the bottom. We want to then put the old base, that was x, the old base, downstairs. So he goes in here. Alright? So he becomes the argument of the log downstairs, and the old argument, that was 2, stays upstairs. Okay? And we can change that then to whatever base we want. In this case we want it to be base 2, so we'll put down base 2 there. Okay? And if I was to simplify that, what it becomes is a log base 2 of 2 is 1, and it's all over log base 2 of x. So that is what we're going to turn all this into. Log base x of 2 is equal to 1 over log base 2 of x. So if I rewrite the question, it'll look like this. 4 times, now it's 1 over log base 2 of x, 1 over log base 2 of x is equal to log base 2 of x plus 3. Okay, so what we have here is we have an equation with log base 2 of x, but a problem over here is that we have log base 2 of x under the line. Okay, so rather than trying to bring them together and simplify, an easier way to solve this was would be to let some new letter, for example y, be equal to this variable thing here, log to the base 2 of x. So this is called substitution. All we're doing is we're taking out taking out log to the base 2 of x and putting in y. We'll solve that equation for y, and then we'll come back and unsubstitute and solve for x. Okay, it does make life a little bit easier. Okay, so let's sub in our y. So instead of log base 2 of x, I now have just a y. So see how it makes it nice and simple. That is equal to, this is also a y on the right hand side, plus 3. That's a nice straightforward algebra equation. Let's solve that quickly. What do we have to do? Well, we see there's a fraction in an equation, so I'll need to multiply by that denominator all the way across to clear the fraction. So let's multiply by y, every single thing left and right. Okay, so all of this guy gets multiplied by y, the y gets multiplied by y on the right, and the 3 gets multiplied by y. Right, we see a cancellation at 1 over y times y. That's going to cancel. Same as a half times 2 would be 1. Okay, and what's left behind would be 4 times 1, which is just 4, equals y times y, y squared, plus 3y. Okay, again it's like a quadratic, but we need to get everything to one side, so let's subtract 4 from both sides. What happens then is I get y squared plus 3y minus 4, and on the left I get 4 minus 4, which is 0, and I have a quadratic. Okay, so let's just come down here a bit, and I'm going to solve this quadratic now for y, remembering that we still have to unsubstitute y equals log base 2 of x. Okay, so 0 is equal to, let's get some factors going on the right hand side here. It's a y squared equation, so that can go into brackets as y and y, and the factors of minus 4, that will add up to positive 3. That will give me plus 4 here and minus 1. Okay, so I have two answers to this equation: y equals negative 4, the first factor, or y equals 1. Those are my solutions for the y, but I have to still unsub, so don't forget to unsub the y equals log base 2 of x. So now unsub y equals log to the base 2 of x, which means wherever we see y, I'll go back to black ink for this. Wherever I see y, I'm going to put now log to the base 2 of x. So that is equal to minus 4 or 1. Log base 2 of x equals 1. Okay, that's two log equations. I can't work out that left hand side in my calculator, so I'll go to index notation, which gives 2 to the negative 4 is equal to x, or 2 to the power of 1 equal x. Okay, 2 to the negative 4, that's 16, check your calculator if you want, equals x, or 2 equals x. Okay, there's still a bit more work to do. We need to check to see both those work in our original equation. So now I'm going to actually write down that original equation again because it's gone up the screen a bit. So let me just rewrite that very quickly. The original equation was okay, 4 times log base x of 2 is equal to log base 2 of x plus 3. And I'm going to substitute in, so I'm going to check by substituting in those two values for x. So first I will check x equals 1/16 in that original equation. Okay, so let me just write down everything here, except I'll leave the x's out and I will write them in later on in a different color. Okay, so let's go in here and put in that 1/16. So on the left hand side he's a base, log to the base 1/16 of 2 by 4, and on the right he's the argument, log to the base 2 of 1/16 plus 3. Okay, and if I go to my cut, so it's 4 times second function pi, and the base is 1/16, and the argument is 2. That gives me -1. Okay, so it's -1 there. Log base 2 of 1/16 plus 3. Okay, let's check that. Log base 2 of 1/16, second function pi, base is 2. This time the argument is 1/16. That's -4. And that gives me -1. It's -1, so that's good. I should of course have put question marks over these because I'm checking. Okay, so that's okay. I can accept that x value as an answer to the equation. Now I'll check the other guy, x is 2. It's possible they both might work, so let's check both of them. So I'll check x equals 2 in my original equation. And I'll just empty out the x's. So this time it reads 4 times log base 2 of 2. Is that equal to log base 2 of 2 plus 3? Okay, and log base 2 of 2 is 1, so that's 4 times. So log base 2 of 2, that's just equal to 1, so all that goes to 1. On the right hand side, all that goes to 1. So I'm left with there is 4 times 1 is 4 times 1 equal to 1 plus 3, and of course the answer is 4 equals 4, so that's also okay, which leads me to conclude that both of those values for x are valid solutions.